if you were to take everything that exists, every star, every planet, every grain of dust, and place it on a scale, what would it weigh? And how many individual atoms would you actually be counting to get that number? To find out, we start with scale. 11 Earths fit across Jupiter. 10 Jupiters fit across our Sun. But our star is a speck compared to supergiant UY Scuti. Hollowed out, you could pour roughly 6.3 billion Earths inside it. Objects of this size feel incredibly dense and crowded to us, but the real challenge of weighing reality isn't measuring these massive bodies. It's calculating an environment defined almost entirely by absolute nothingness. We tend to picture our solar system as a tightly packed neighborhood of planets, orbiting neatly next to each other. Looking at this map of planetary orbits reveals reality. Even swapping our Sun for the colossal UY Scuti, the gaps between the inner rocky planets and outer gas giants like Saturn and Neptune remain immensely wide and entirely empty. Once you leave a solar system or a galaxy, the emptiness becomes a hard vacuum. Across the vast stretches of deep space, you will find an average of just one single atom per cubic meter. Taking inventory of the universe means going on a cosmic scavenger hunt. You are searching for tiny, isolated pockets of matter hiding within a nearly infinite void. Rather than trying to count individual stars scattered across that vacuum, astronomers zoom out. They count the largest clusters of matter we can observe, galaxies. This diagram shrinks the Milky Way down to the size of the continental United States. At this scale, our Sun is the size of a single red blood cell, and our entire solar system fits perfectly within the ridges of a human finger. Now, take that massive structure and multiply it. Observations suggest there are roughly 2 trillion of these galaxies scattered across the observable universe. Combined, those galaxies contain up to a septillion stars, a 1 followed by 24 zeros. That is quantifiably more stars in the sky than there are grains of sand on every beach on Earth. To accurately weigh 2 trillion galaxies, astronomers break them down to their most fundamental, abundant building block, hydrogen. They calculate a theoretical value called the Eddington number. This represents the total estimated count of protons, the heavily massed nuclei of hydrogen atoms in the observable universe. This calculation yields an unfathomable 10 to the 80th atoms. Plugging this head count into the universe's critical density converts that particle count into a measurable mass. The final cosmic tally for ordinary matter is exactly 1.5 times 10 to the 53rd kilograms. We've counted octillions of stars, tallied 2 trillion galaxies, and measured 10 to the 80th atoms. But those numbers do not represent the whole universe. This pie chart shows reality's full composition. All ordinary matter is a mere 4.9% of what exists. Another 26.8% is cold dark matter, an invisible scaffolding keeping galaxies together. The remaining 68.3% is dark energy, driving the universe's expansion. Everything we can measure is the exception. In our daily experience, matter feels solid, dominant, and omnipresent. Yet we are floating in a shadow universe dominated by forces we cannot touch or see. In the context of that vast dark expanse, Earth and all its life forms represent less than a fraction of a single quark inside 1 grain of dirt. If you wiped away human existence, our planet, and our star, the loss wouldn't even register as a rounding error on the cosmic scale.